Hi, Ivy Bound sixth grade. So I know that we have gone over some of this in class, but I did want to review and create assignments based on a review just to make sure that everybody really understands all the material that we learned. And it can be a great review and a great way to solidify everything that we have learned. I know that there aren't too many lectures that I've gone over with you since I've taken over, but I still wanted to make sure that we reviewed what we needed to before we moved on to new lessons and new chapters, especially because some of you might have been absent for these important lectures. So whenever I post a lecture like this, I'll be going through each slide and I will be describing each slide the same way that I would do a lecture. Now, you obviously can't ask me questions while you're watching the video, but I do have office hours and that is posted on your schedule. So make sure you see that schedule where it says week of, and then it shows you which dates that the week shows. Just go open that doc with the schedule and make sure you check that schedule to see when your grade has office hours with me. And I'll be actively checking my emails and I'll be actively on Google Chat just so that you can communicate with me and ask me any questions about what assignments are due. Just know that I'll have 3 graded assignments. The 3 graded assignments will be 2 discussion questions that you will have to answer and respond to. Make sure you respond in complete sentences and make sure you respond well because you will be graded on it. And another one will be I will give you a supplemental video for you to watch. And on that video, you just have to take notes, 5 bullet point notes, but each bullet point does have to be in complete sentences, and do this on lined paper. And I will be collecting this upon your return when we see each other again in school. Now, just to get started, this lecture is going to be on the geologic time scale. I'm going to be going through each slide. The geologic time scale and the geologic history of our Earth, we already went over that it is 4.6 billion years of history. Now, the geologic history is broken down by geologists into eons and then even smaller than that, eras, which are then broken down into periods, which is then broken down into epochs. And you can see that in the visual representation of eons being the biggest right there in that image, and eras being broken down into smaller, and then periods are even smaller, and then epochs are even smaller than that. Now, we discussed the best way to remember this, which would be EEPE, eons, eras, periods, and epochs. In case you do forget, it is EEPE. And I found that this is the best way to remember it, eons, because eons ago, when we talk about eons, it seems like the longest time. And then eras, and then periods is the only periods. And epochs has the most letters, so I said that would probably be the smallest because it's broken up into the most letters or pieces. That's how I would remember it. Now, moving on, we went over the 3 major eras that we will be discussing in the weeks to come. It goes the Paleozoic era, which is the oldest era. I call it the Papa era. And then the Mesozoic, which is going to be that middle era, the Mesozoic, middle, MM, and then Cenozoic, which is the newest era, which we currently are in. These divisions in time and these divisions in the geologic time scale were marked by geologists based on these rock layers. So in each rock layer, geologists saw some fossils in one rock layer that they didn't see in the next rock layers, and they didn't see those in the following rock layers, and all these different fossils that they saw in each rock layer is kind of how they determined which era is going to be which. Now, the divisions in these eras were determined by these giant extinctions. So after the Paleozoic era, they determined the end of it by this giant extinction. And then after the Mesozoic, they determined the end of it because of another big extinction, and so on and so forth. Now, you can see in this visual graphic representation that each little drop right there in the graph where there's like these peaks going downward, it shows the percent of loss. So each peak downward is going to be a mass extinction. Now, each mass extinction shows a drop because there is a huge extinction or a drop of percentage of diversity of the species on Earth within this short period of time. These sudden changes in the fossil record that you see represent when large populations of organisms died or became quote unquote extinct. And it shows that there hasn't just been one, but there have been multiple mass extinctions. Now, what could cause a mass extinction? Climate or sudden environmental changes, or any type of a change where organisms cannot adapt as quickly. And that could be a sudden climate change or environmental change. When an animal cannot adapt quick enough, they're going to die. They are unable to adapt to the new surrounding and survive. Now, all organisms depend on the environment for their survival. And what makes different environments are the weather. Like there's areas that are cold, there's areas that are warmer, there's areas with more wind that are drier with humidity, and so on and so forth. So if their environment or their weather or any type of climate changes too quickly for them to adapt to the change, they will die. An example was that dinosaur extinction. When the meteorite hit is what scientists hypothesized, or they also hypothesized that there might have been a large volcanic eruption. There was a big change in their environment and the weather. It's not that the meteorite hit them and crushed them and they died. It's that there was a potential cause of chemicals or fumes or dust that blew into the atmosphere and blocked out the sun. Same with the volcanic eruption. All those fumes and chemicals and smokes blocked out the sun. And ultimately, it caused all these rippling effects that changed the environment that the dinosaurs lived in, and they could not adapt quick enough. And that is why they went extinct. Now, in terms of geography and evolution, there are two ways that we went over previously, and I'll go over them again, in which geography affects evolution. The first one that we discussed were land bridges. Now, when land bridges are created, it's pretty much when continents collide together and creates this type of a bridge that connects two continents together. When these are created, species from one area or one continent are now able to cross over to another continent and cause this level of evolution because they start to adapt to these new lands or new continents that they are now able to cross into. Now, a visual representation of this is this image right here. You see that there is this land bridge that was created, which allowed these people, as well as the mammoth and the buffalo right here, to cross over, and then they will now adapt to the new environment that this new continent that they have access to will bring. The second way that geography and evolution work together, or geography affects evolution, is geographic isolation. Geographic isolation is the separation of a species or a population from the rest of its species because of some sort of physical barrier. It's when they get separated, they are isolated or separated from each other. Examples of barriers that can form like this are mountain ranges or canyons where there's a split in the floor due to some sort of an earthquake, or it can be water barriers like oceans or rivers due to heavy rainfall. And now this is the image that can show that these organisms can get separated by geographic isolation. And when they adapt to the new surrounding, as you can see in this picture, there is a river or water that separated these deer. When they do get separated, one side of the land might have more sun and one side might get more clouds, which might affect the coat or the color of these deer. Now, when they're isolated, one side with an environment that is different from the other side ensures that these species adapt or evolve to that environment. And that's how you get two different colors of deer, or that's how you get different types of the same type of animal. Like there's a black bear, there's a brown bear. Whatever their new environment is what causes them to adapt and change and look different, even though they might have all started out the same. So we went over right here, land bridges, and then geographic isolation as the two type of geography changes that affect evolution. Once again, just to review, the two ways that there's a change in geography and how it affects evolution are land bridges and geographic isolation. It's super important to note that changes in geography are very slow. It is not fast. It is not rapid. So that probably means that when it comes to adaptation and evolution, they are also very slow. None of this is fast. Now, moving on back to that geographic time scale, the Precambrian time is the biggest chunk of the Earth's history. It is 90% of the entire Earth's history. Precambrian was before Cambrian. It was Precambrian, and this was before multicellular organisms appeared. So complex organisms did not appear until the Cambrian time. So Precambrian, which is the biggest chunk of Earth's history, had pretty basic organisms. So 90% of Earth's history had basic organisms. It wasn't until this Cambrian time where all these organisms became complex. As you can see in Precambrian time, once again, just to repeat, it is 90% of Earth's history. So the biggest chunk of time in Earth's history, everything was soft body, unicellular, weak, and pretty basic. Examples of such species would be jellyfish, coral, segmented worms, algae, very, very basic life forms. And most of them all went extinct before the Cambrian. Now, it was this Cambrian explosion event where there was a sudden appearance or explosion of these complex multicellular life forms. This little picture right here is a trilobite, as you can see. These types of organisms first appeared during this Cambrian explosion. So majority of the Earth's history, everything was basic and simple. And it wasn't until this huge event called the Cambrian explosion where all these new life forms with hard exoskeletons were formed. And we know this because these hard exoskeleton life forms are easily preserved and fossilized. So we can now see many of these fossils and these organisms like trilobites that appeared during this time. Now, the Cambrian explosion, this is like a graph that shows you that there was this huge increase in diversity. The key word here is diversity. So all of a sudden, all these different types, diversity meaning many different types, there was a huge increase in this in a very, very short period of time, as you can see here, during this Cambrian explosion. That's pretty much all that I want to go over in terms of geologic time. We will go into depth about what happened during the Paleozoic, Mesozoic, and Cenozoic eras. If you do have any questions, make sure you do ask me during those office hours. Make sure you complete the 3 assignments based on the schedule that I will post. And you can always feel free to email me at any time if you do have any questions about assignments or questions about the geologic time scale.